Hello everyone, welcome to my YouTube channel Data Partnership. So today I will discuss about uh, how to estimate irrigation potential of an area. In my last video, I showed you that how to calculate, how to estimate the rainwater potential, rainwater harvesting potential in from different households. So collectively, I took the sample data for each and every household, then accordingly calculated the rainwater harvesting potential. But this time, this video, mainly the objective of this is to, yes, to estimate how much irrigation can be supported in each village. Earlier, it was household level. We calculated household level water harvesting. So now we are talking about how much irrigation can be supported in each village based on two factor. One is rainwater harvesting potential, and another is net rainfall after accounting for soil retention. Right. So. What we have done is we have used input data for rainwater village level rainwater harvesting data, where we have village ID and rainwater harvesting meter cube per year, like this one, right? What we did last time is we have household. So I'm just assuming that if any village have 200 house or 300 house, 500 house, so accordingly I have calculated for village level, right? So values are something, it's a random, right? You can see my previous video. Accordingly, you can calculate for a village level. It may be more or it may be less. And area and rainfall data. So this will be the second one is area and rainfall data means we have every village, we have monthly data means January to December. And one is soil retention and area of the village. Soil retention mainly it depends on the texture of soil, like if it is loamy, then how much it's how can water it can retain, sandy or something like that. So I took it some from the internet, right? So you can check from by yourself from the internet, and I will also check. I will share source for, there are different sources. And another one is I have crop water demand. So we have crop water requirement, but each crop we have different crop water requirement, right? So we have this. So I've just randomly taken how much crop area in any particular village. For paddy, it's a 200 a square hectare, or wheat, it's 150 hectare every village. So this data I have is the sample data, right? So this is so what I have done is based on that. It's calculation actually calculations. It's not that we have annual rainfall. We will take it from monthly values. Net rainfall, annual rainfall minus soil retention, right? Net rainfall volume we will take like this, and total water available is net rainfall volume plus rainwater harvesting, and total crop water demand formula will be this, and irrigation potential will be this, right? So this is, I did not use this one here, but you can see here the crop, and this is the crop water need. So I have taken it from FOA website. So FOA, so you can FAO, right? If you see, click here, then it will go to here. It's a food organization, right? So food and agriculture organization, it's a international organization. So you can check. So I have taken from here. This data I have taken from here. So you can check at your level. All right. So this is the general calculation I will show you in using Python, and this will be the interpretation. So let's start it, right? So I will go to Anaconda, and will activate my USB1. So this is my folder. I will just paste here, and Jupyter notebook. Oh, no, no, it's wrong actually. Yes, CD. I'm using another one, this one. Mm. Each and every time I'm doing this, right? Because if any newcomer or beginner start to learn Python or Jupyter Notebook, so I thought that he can take the advantage of this, right? So maybe I will take my earlier this one. Let me check. This one, water management. Yeah, this one I have done my last video, right? So I'm starting from here because it was basically the rainwater harvesting. It was total rainwater harvesting. This one, right? This column, rainwater harvesting meter cube per year. But it was the household level. Right now, it will be at the village level. So let's just start the thing. So I have what we have done is I have data in my folder is called this one, uh, water use analysis. This is I have so I have taken it like village ID, and every village has rainwater harvesting. But I have taken the randomly based on the just some assumption, right? If you try to calculate based on my earlier video, you can do for whole village, right? So and this one is so what I will do is you can start here, load the house RWH DF equal to PD dot read CSV water use analysis dot CSV. Right. Yeah. So what I will do is I will write here import. Okay. So what I will do is I will run whole because I already defined. I'm just starting from means I'm including my earlier notepad notebook also. So I'm just continuing the process, right? Maybe in future I will share this file to you guys. So RWH DF. You can see. So this is our uh, data frame for rainwater harvesting potential. Next is that what we will do the rainfall DF. Rainfall DF equal to same thing. I will just copy and paste here. Right here we have a file called irrigation potential.csv. Right? Yeah. Now you can see rainfall DF. Yeah, you can see we have all the data here. Dot right, right, HEAD. This is the thing, right? So now what I will do is I will aggregate the rainwater harvesting volume at village level. So how can we do that? No, what first we will do the we will calculate the rainfall yearly rainfall DF, or we'll say annual rainfall, right, in equal to rainfall DF dot ilog. This is one of the Python property ilog. So now you can see the beauty of this, comma 1 to 13 means it's a 12 and 13 is the next one, and then sum x is equal to 1. Yeah. So now you can see rainfall DF. So we have annual rainfall here, right? Right. Please read about this ILOC. It's a very important. I will share a separate video for the ILOC block, right? so that you will have no confusion. You can see it's calculated horizontally, right? And gives total here. So we have this one lock also like this. Now then we will calculate rainfall. Now we have total now rainfall here. So the net rainfall. How much is the net rainfall? The net rainfall in mm, right? How we will know that? How much is rainfall is there equal to rainfall df, uh, say annual rainfall from here. I will take it is from here minus basically how much it is available. This is the means rainfall happens, actual rainfall minus whatever soil is taking. After that is the net, right? So how we will minus it soil this one. Yeah. So now you can see rainfall df. Yeah. So we have net rainfall amount, right? I am doing each and every step so that you will have it. Otherwise, I can write this code in one one this column only, right? So that I want to explain it to each and everybody, right? So now what we will do is now our rainfall data is in and our this rainfall harvesting is meter cube. So I will now means basic I will convert into the volume rainfall conversion into volume. So how we will do that? Rainfall df net rainfall net like this, copy this net in cube, right, equal to what will rainfall df from this, right? That's very important. Divided by 1000, right? Multiplied by rainfall df with an area, right? This is simple with an area into rainfall, right? So area HA and multiplied by, yeah, this one. So now you can see rainfall df is like this. So now we have net rainfall is this, and what, and like this. So now we have this net rainfall in meter cube. Now we will merge this with the rainwater harvesting potential, right? So we have to, so let's do it. So RWH df dot rename columns. It's not required, but yeah, you can do this one. RWH RWH meter cube, right? And close it. And let it in places true. In places right? And run it. Means everything works. So now what we will do is we'll create a merge df. Merged df equal to pd dot merge. Which one? Rainfall df, right? And rws df both on which one? Which is the common thing here? Village one. This village ID is common in both. On village ID. Village ID. Correct? So run it. Worked. So what next? Merge df. Now we will calculate the total water available. So how we will write that? Total water available. Total water available, yeah, in meter cube equal to merged df, right? Net rainfall. Net rainfall meter cube means this one. I'll just copy from here. I'll put this here, right? Plus which one? MERGD merge df. Okay, RWH, this one, right? R RWH meter cube, this one, right? Something is wrong. I think I have to do this way so that there will not be any confusion, right? Now here RWH here you can see, right? We have changed it dot head to, right? Now I will just cut it here. I will put down here and we merge here. You can see it is here now, right? Dot head to, then merged df. Sometimes spelling writing is also important. Merge df total available water meter cube. Yeah. So we have missed something here, right? So now we can see merged df will looks like this. So we have net available water, right? So I think we are very close. So now one thing we call crop df. So now what about crops, right? Crop equal to ed dot read csv crop water v1. This is my file I have created. It's a sample again, right? You can see crop df. Yeah, you can see we have village ID also here. So we have crop different. I showed you the sources also. So it's a two, right? So then what will be the demand? So if crop is this, then what will be the crop demand? Uh, Crop df or water demand. Water, if this is the requirement of particular crop, then how much the water demand for each village, right? So this is right equal to crop df With the crop water requirement, this one. We are also converting this into meter cube. So divided by 1000 close multiply with crop TF area. Similarly, what we did earlier, right? It's a very important thing you are learning today. I'm 100% sure it's a whole project itself, a project, right? I can tell you this is a project, means anybody can create a project out of it. So it's unmatched. What I have done wrong. Crop DF, yeah. Water demand in the crop DF, crop in. Oh, additional one. That's all. Sorry. So now you can see crop DF dot head 2. Yeah. So we have water demand in metric cube. So now we will know village water demand. How much is the water demand for a village? So village crop demand equal to crop TF dot group by village ID, right? Village village ID, and what we need village ID? Water demand. Water demand, this one. I will just copy this one from here. This one. Dot sum, right? No, that's it. Yes. So now you can see village. You can see every village has this much of demand. Dot. Right. We would like to see in better way, right? Ah, whatever. Anyway, I don't know why it is happening, but I will write it to avoid any. Okay. Yeah. So it looks like this. Right. So now we have to merge the calculations. How to do? So we have final D of them. What is there? VD dot MER merge So merge, what we will do? We will take this one, merge TF, right? And this one, village water demand, correct? On village ID. Village ID is common for all, right? Village ID, how equal to left. Yes. So now you can see the final tier. This is the final tier, and this one is our water demand, right? So it's very interesting. Now we are going to come irrigation potential. Now we'll know. So from this final DF irrigation potential in percentage, yeah, equal to final DF, yes, from final DF total water available, right, divided by final DF water demand, right, and multiplied by 100. So now final DF. You can see this is our irrigation potential. Now you can see 100% to 120, 78%. This is coming. So where is 100 or 100 percent is there, then it means they have enough water. Means they have access. And wherever is the less 70 less than 100, it means they have water deficit. So then intervention is required. So basically here I wanted to show that the water available is for village one. This is the water available. Water demand is this, and irrigation potential is meets demand fully. Suppose here 53% means water limited needs augmentation or some intervention is required, right? And so this is the potential thing for us. So we can plot also, right? So I think you guys should plot by yourself. I am giving it to you. So please plot by yourself. If not, then I will plot for you. And next video, I will come with more analysis like this. So which will help you in the project. So guys, please subscribe, share, and like my videos because a lot of effort I have put on this, right? And I'm trying to 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 make uh, impactful videos so that it will help you in a project or in career or in your learning, right? Thank you, thank you.